Okay. Welcome everybody to this brown bag. So this is just going to be a really basic introduction to MongoDB and how to tie it into a C# application. I want to go over a little bit about what is Mongo and how to do some basic queries and stuff, how to create data, and then we'll build a exceptionally simple application to just show how to do some simple operations in C#. Yeah, so let's get started. So what is MongoDB? I pulled this straight from Wikipedia. It's a free and open source cross-platform document-oriented database. It's classified as NoSQL. MongoDB avoids traditional table-based relational database structure in favor of JSON-like documents with dynamic schemas, making the integration of data in certain types of applications easier and faster. So here's the one thing I really like about MongoDB is, in contrast to SQL, and I've been a SQL guy for years, but the thing I really like about Mongo is what they say in this last part. It makes the integration of data in certain types of applications easier and faster. You can make your Mongo data match your data model almost perfectly. Anyway, that's one of the things I absolutely love about Mongo. So Mongo stores data. It uses JSON and BSON. And, a lot of people are like, oh yeah, MongoDB, that's a JSON database. But in reality, it's actually stored in BSON, which is a binary form of JSON. And I'll go over that a little bit in a moment. And then I touched on this a second ago where, in a traditional SQL database, there is a mismatch between the application, or there can be a mismatch between the application and the database schema. You may, and that mismatch is often to support stuff like joins and other database operations. You create your database differently. And while it doesn't necessarily support joins, you've modeled your data in such a way that it matches your application logic better. I just mentioned that. Yeah, MongoDB doesn't have joins as they are seen in SQL. And matching your data model is more seamless. Indexing in Mongo, I actually think is super cool. I'm not going to go over it today. Maybe we can do that another day and for another brown bag. But I actually am really impressed with Mongo's ability to support indexing and how easy it is to set up. So let's talk about JSON and BSON for a second. JSON, I love JSON. I use it all day long on my current project. It's a great way to organize your data, and it's easy to read, it's easy to write, but it has some limitations. It doesn't have some very complex data types. You got your strings, you got your numbers, you got your booleans, basically. In a database environment, you have a lot more database types. For example, you have dates. That's probably the best example, actually, is dates. If you just create a JSON object, you'll have a title. Well, in this case, I have a title, and then you might have a date. Okay. Now, in traditional JSON, you store that date as a string. In Mongo, if you actually go back and look at your database after you've created a date object, it'll have this ISO date wrapper around it. And this is actually to support better date queries. This is actually what BSON looks like. I also pulled this straight from Wikipedia because I was having trouble finding a good BSON example I liked. But hello world, that's the JSON object, and then this is the BSON that is the equivalent. And you'll notice on that second line there, it has a type is string. So in other data objects, you'd have like a type is, a number, or different types of numbers, or date. and then it has the object, and then not the object. One of the reasons BSON is super cool is because it actually allows Mongo to go in there and update single records, single data points within a record, as opposed to having to replace the entire JSON object in the database. I've worked with another JSON database where if you want to update something, you pretty much just update the whole object. And from a performance point of view, it can actually be kind of detrimental. So Mongo actually makes it super straightforward to go in there, update one field in an entire document, and then you're done. You guys got any questions about the BSON stuff? It's really, I'm kind of going through this pretty quick, but I just thought it was important to understand that Mongo, while it is a JSON database, it's not really a JSON database. It's a BSON database.
Does it inherently update the record? So if I supply BSON data document, will be one field being changed in that BSON document, does it automatically intuitively know that was the field that updated? Okay.
Yeah, it recognizes that that's the field that was updated. And the cool, yeah.
Will you repeat this question?
Oh, sure. So the question was, will it update the single field?
Yes.
Yeah, it'll update a single field without having to update the entire document.
But if I supply the entire document to be updated.
Oh yeah, it'll do that. If you say, yeah, I want to update the entire document, it'll do that as well. Okay. One of the cool things, and I'll show you guys this in a bit, but one of the cool things about Mongo is it actually has a replace command and an update. So you can actually do, if you just want to do an update, that's great. But if you really just want to replace the whole document, you can do that too. Yeah. Okay. So, I was going to say, sorry, I was going to say, even though the data is all stored in BSON, you actually work in all JSON. So you don't have to go in there and type, awful looking hex code. You actually are working with JSON objects. You're passing those JSON objects to the Mongo server, and the Mongo server actually handles that transition between JSON and BSON. Okay, so I wanted to go over just a few simple queries. There is if you, and I'll show you this to you in a bit as well. After you get Mongo all set up, there's a console you can use just on the command line where you can look at your databases, you can look at the different collections, and I should probably say that for as well. In the SQL environment, you have your SQL database, you have your SQL tables. Okay, each database is made up of tables. Those phrases are analogous in MongoDB to you still have a database, but then instead of a table, you now have a collection. And you can drop whatever you want into that collection, though. While it's in your best interest to keep collections, similar data types, you don't actually have to do that. Okay, so what I've done here is I've created just a sample data set. Super simple, right? We got 3 JSON objects here, each with an ID and a title. And this is how you would view them if you were looking at the data in the database. For all intents and purposes, just assume that it's all BSON, but we're working in JSON. So we got 3 JSON documents here. Now, on the console, you could type in a query. And I know Harry Potter's not sci-fi, but you could say db.sci-fi.find, and then you build this little JSON object where you say ID:3. The result would be just a single JSON document that matches that ID. That's pretty straightforward. I mean, that's your basic query, right? You can make the queries a little more, and I made a typo there, not bad. You can make the queries a little more involved. If you want to get all of the documents where the ID is greater than or equal to 2, your result would be documents with an ID of 2 and 3. The typo I made, and I apologize for this, there should be a $sign right in front of this, right in front of the G in the GTE. Okay, so these are just super simple queries in Mongo. And this isn't actually how you would make them look in C#. This is all just on the console, the admin console that Mongo provides. Okay, so do you guys have any questions about that?
Sci-fi is your collection, correct?
Yes. So in this case, I don't have the database name here, but yeah, Sci-fi is the collection. Find is the operation which you're going to do. You can actually pass an empty find, just open close parentheses, and it'll give you everything in the collection. Sorry, you had a question?
Right. So on the second query here,
Yeah.
get rid of that. You didn't return those as a array, or did it? And you just didn't.
I just didn't type it in.
Okay. But it would be as an
Mhm.
so.
Yeah. I typed this in PowerPoint. So I'm actually going to pull up the console here in just a bit, and I'll show you exactly how this works. We'll even do the same data points, the same data set. So if you want to set up Mongo, this is how you're going to do it. So you got to go out, you got to download the Mongo server. And let me just show this to you. So you go out. We used to go to mongo.org to get the free version. They've actually redirected all of it. Now you can just go to mongodb.com, come here to download, and then it's supported on multiple operating systems. I've only worked with it on Windows, so you download the installation package. It actually is pretty straightforward. They don't ask you any weird questions. It just installs and you're done. It's going to create, and I will show this to you as well, because this is useful. Let's minimize that. It's going to put it in a folder in your program files. There we go. Oops, I didn't drag it. Okay, in your program files, you're going to have MongoDB server, then your version number, and then bin. So the bin folder applications in it. What you're going to do is you're going to, and let's come back over here, you need to update your environment variables. I mean, you don't have to do this if you really want to browse in, navigate to this path into the bin folder in your console, you can. But if you update your environment variables, you're just going to add the bin record to it. Stand by, I'll show you. You're going to add it to the path. So I know this is kind of small for some of you guys in the back, but there it is right there. And so you just point it to the bin folder. The nice thing about this is then you can call all of those Mongo applications from wherever you are. I mean, it's made for lazy people. You run the command MongoD to get the process running in the background. You can actually set this up to be automatic if you want. So as soon as you start up Windows, you can. I haven't actually done that yet, but anyway, when I want to start Mongo, I just open up my command line and MongoD, and there it is. That you would just let run in the background. You really don't need to, I mean, you can watch it as you actually interact with the database. You can see it doing things, which is great for debugging. But in reality, you could probably just minimize it and you'd be happy. Okay, let's come back over here. So then, because you've added that bin folder to your environment variable, now you can open up just another command window. And actually, let's make this one bigger. You guys see that okay? Is that better in the back, Chick?
Yes.
Good. Okay. So if you actually want to...
Understand it.
Oh, come on. I'm speaking English here.
Well, kind of.
Okay. So if you actually want to get into the database, now you can just type Mongo, and it is going to, now you're connected. That's super straightforward, right? Okay. Let's jump back over to the PowerPoint for just a second. MongoDB makes available the CSharp driver. There are actually drivers for a variety of different languages. So, I mean, if you want to work in something besides CSharp, you could go out and see if they have the one you want specifically. The cool thing about Mongo, or the C# driver, is that it supports link queries. I'm a huge link addict. I live for link. I love typing my link queries. You can do all your basic CRUD operations in your link queries through the driver, and it's just super cool. And there's one specific feature to how it builds the queries and sends them to Mongo, which I'll show you guys when we actually build the C# application. Okay, so we're done with the slides. Let's jump back over. We're going to close that. Okay, so let me show you guys some stuff here in the console. Sorry. Okay. So there's some simple commands. Probably the most basic ones you want to remember is you can say show DBs. So this will show you the different databases you have. In this case, I have one called vehicles, local, ng, and shows. The local one is there by default. When you install Mongo, that's what you'll have. It's just something that Mongo creates. Because I want to start fresh, we're going, you can, we'll just do this. So you can switch to a database, shows, but then I'm going to drop this database. And we're going to what do I get for not paying attention? Okay. Okay, so I'm not going to drop that other one. I'm using it. Okay, so let's just do this. So we're gonna create a collection, or sorry, a database. And here's the cool thing: you don't actually have to say specifically create this database right here. What you can say is you can say I want to use. We're gonna call it movies. Okay. Now switch to a database called movies. And then if you want to, and then you can create a collection. So like I said earlier, this is equivalent to creating like a table. And we can call it sci-fi. Okay? So it says, okay, you've created your collection. Now, we're going to insert a single document in here. What we're going to do is we're just going to build a JSON object right here. You can say ID equal to 1. Title is equal to Star Trek. Make sense? Okay, so hit enter. So the right result there was one document inserted. So now, if we come out here and we say MongoDBs, we have our movies database now. We can also say now show collections, and there's our sci-fi collection. So you can say db.sci-fi.find, and as I said earlier, if you just pass an empty argument here, it's just going to give you everything. And in this case, we have one record. So stand by while I'm not going to type this one out. You can insert larger amounts of data. So if you want to insert an array, you're going to start off here with your square brackets, and then each JSON document comma separated. Does this make sense? Okay. So you hit enter. Okay, so you can see here, inserted is 3. So if we do another find, we now have 4 documents. If you want to do, okay, so I showed you guys some simple queries a bit ago. If you want to find a document where the ID is 3, there's a single document, right? And if you want to find, and then I showed you this query earlier in the slides, but if you want to say, give me where the ID is greater than a certain range, and here's where I missed the $sign in the slides, greater than, we'll say 2. Oops. Okay. should give us 3 and 4. Yeah. I mean, these are super basic. You can string these together with ands and ors and pass in multiple parameters, and it's fabulous. It's quite beautiful. But, okay, do you guys have any questions about that? Sure, go ahead.
Can you index on some of those fields too?
You can, yeah. You could index on all of them. I'm not going to because I don't want to mess it up. It's actually pretty straightforward, but I honestly don't remember the commands right off the top of my head. So, but yeah, you could index on any one of these fields. The cool thing about indexing as well is that you can actually, you don't have to just specify one field. You could say, sure, index the ID field, or actually the ID field I believe is indexed by default. But you can index a single field if you want, but you could index multiple fields, create a single index with multiple fields.
Okay.
And then as you pass in queries that are querying multiple fields, that query specifically would come back faster. Cool. That makes sense? Okay.
I have a question.
Sure.
On the underscore ID, is there best practice for like auto-incremental values or how those get populated?
I don't got a good answer for you with that, honestly. With my IDs, on all my applications, I like to use GUIDs. And so they're not incremental. So it's not a problem I've had to deal with. Sure. You had a question?
You can insert any kind of object into a collection, right?
Oh, yeah,
Are there
totally.
ways that you can restrict what you insert into the collection?
There are, and I'd be happy to show that to you, again, if I could remember the command off the top of my head. But you can actually say, in this collection, do not allow these rules. You can set up rules for that.
So you set up rules to say, I expect my JSON object to have these fields.
Yeah, and you can also set up rules to say, like if it's a number, for example, you can say it has to be within this range of numbers, or stuff like that. You can get pretty crazy with all of this. The other cool thing, and let's do another insert. So someone give me a movie title. I'm not sure what. Dark Knight. And we'll give it a different ID. Then okay. So you can run that. We got one document inserted, and now if we look at all of the documents here, they don't all match, but it says, yeah, that's fine. And your queries still work too. Actually, let's do that one. So I mean, it's still returning one, even though the data doesn't match. And this still works really well in C# as well.
And what if you wanted to update all the records? You'd have to find them, all the records to update the rating, for instance, and have them all have a rating field if you needed to.
If you needed to, you could. Yeah. My recommendation actually would be to just update your application logic to kind of populate a default. But you can actually write a command here that would go through and find all the ones where it's missing and populate a value that you specify. So yeah, you can do that if you want to do like a mass update like that. But the cool thing is that the data doesn't have to match if your application can support that sort of logic. Sure. Good question.
If you wanted to query and find out which ones didn't have a rating property on them, would you specify rating of null, or how do you find those?
Yeah, we can try. I've done it before. I can't remember specifically how I did it though. Okay. Yeah, you can do it. Again, the operation escapes me right now.
Got an extra phrase at the end.
Oh, I do, yeah. There you go.
Oh, right there.
Yeah, and then I want to try this again now. Nope, okay. Let's try. There we go.
So what happens
field disappear?
Or does it become rating?
Yeah, I'm not sure. I would assume that the property would still be there, but it would just say null in it. Yeah, that's a good question. I've not tried it. Okay, so let's dive in now to the C# stuff. Because this is cool, but okay. So I took the liberty ahead of time of just creating a, oops, I didn't drag it over there, sorry. Okay, just a very simple console application. I thought about doing something a little cooler, but I decided in the interest of keeping this application from having a lot of clutter, and we would just set some breakpoints and inspect the data as we go through. So the first part I want to start off out with is, let's create our data model. So we're going to do public, we're going to call it truck. We're going to give it an ID. And this is where I use my GUIDs. So, but I still store them as a string. Make. And we're going to say int is year. Okay, so it's a pretty straightforward model object. The other thing, and this is probably the most important part, is you got to have a connection into the database. This is okay. So this is my personal preference on how to do it. I don't know how many of you guys have used link to entities, or something like that. You have your database context object, right? Yeah, which is nice because you have all your entities in your context object. I kind of like that model. So what I tried to do was create a pattern that I could use to mirror that. So. And this is my disclaimer. I haven't actually tested this for performance, so this could be the wrong way to do it. But I like the syntax. So I like to create a public static class, public class, sorry, call it DB. And then this is going to be my connection string. This is your link to the database. And because I'm lazy, I'm going to copy it in. Okay? This would change in your production environment. Or if you had different development lanes, it would change there as well. Okay. Okay, so before we can go further, we have to add the Mongo libraries. So we're going to come in here to NuGet. There. We're going to browse for MongoDB, and we're going to install the MongoDB Driver. Just the latest version, which is 2.2.4. In case you guys care, 2.3 is in beta. Actually, I think it's in the release candidate now. Okay, so that finished. I apologize for those of you back there, but we now have three libraries here. We got MongoDB.bson, MongoDB.driver, and MongoDB.driver.core. What we can do now is this gives us the Mongo client. Okay, so we're now using MongoDB Driver right here. So we have our Mongo client, call it client for the sake of originality. Mongo client, and then we're going to pass it the connection string. Now you could, ideally in a real application, you would store your connection string in a configuration file. So you don't have to publish a new build if you want to redirect it to a different database. Okay, so then we need to create a pointer to the database. So in this case, it's iMongo database. And I called my database private set. And we're going to pass it the client, which we created on the line above. We're going to pass it the client and tell it to get a database. And we're going to call it vehicles. Spell that right? Yep. Okay. Vehicles, because we're going to match the topic of trucks over here. Okay. So that's our database. Now we can create a link to our collection with that database. So we're going to say MongoDB.collection. Here we're going to say, okay, this collection has a type of truck, ensuring that the data that gets saved in our database will match the data model in our application. Like, what did I do wrong? Okay. I didn't give it a name. Yeah. IntelliSense is all off here. Then accessing our database object on the line above, we say get collection. It's going to be a type of truck, and it's going to have name of trucks. Okay. Is there any questions about this part right here? It gets better. So if you want, okay, so let's make sure I have. So now, because I don't want my application to just end. Okay. We're going to create a new truck object. Call it truck. Initialize it. We're going to say make. Now, anybody that owns a truck knows that you will have a Chevy. Stand. And your year. We're going to go with 2017. No, not that year. 2017. Okay. We have our object. It's not in the database yet. We can say DB, so we created our static, our context object basically down here, DB. DB dot trucks dot. These are all the different libraries. You got inserts, replaces, deletes, updates. So we're just going to do an insert. We're going to do an insert one. Now, interesting thing here, there's actually an insert many. Oops. And it actually accepts an array of objects. So if you wanted to, you could pass in a whole grundle of data. We're not going to. But, okay, so we're just going to pass it our little truck object we just created. And there we have it, okay? So set a breakpoint right here. We don't need to, actually. Okay, let's run it. It's just going to flicker real quick and then be gone because we're not doing anything. We're not displaying anything. But you come over here to the console now, and you say, show DBs. We now have a new database called vehicles. Use vehicles. Say, show the collections. There's our trucks collection. You can find, and there's our single truck. There's actually a useful little thing you can say, find.pretty on right there on the end, and it will format it so you can actually read it. You guys got any questions about that? Like, I love this, you know, it's just easy. In my mind, it takes, you don't have to worry about application logic, or sorry, database logic anymore, because most of what you're doing is just mirroring the logic in your application, and the database takes care of it. It's, yeah. Okay, so let's do this now. Let's create a few more objects. I have typed them ahead of time. What I've done is I just said db.insert, and then I just initialized a new object right there in the parentheses. We're going to have another Chevy that's a 2005 and a Dodge that's a 2009. So if we, let's do this. I want to start with a, Yeah, let's start clean. Okay, so we've dropped our database. And if you really want to know for that I'm not lying, our vehicles database is gone. So shouldn't see any difference other than we now have should have got an easier word to type than vehicles. And now we have our 3 documents here. Okay, so let's do a query in C#. We're going to set a breakpoint here because we're going to, with this one, we're going to inspect the data that's coming back. So let's say we want to get back a list of trucks, store the results in a object, trucks.find t.year is greater than or equal to 2009. And we're just going to send it, pass it to our list. That makes sense? Okay, so let's run it. And right here, if we inspect this, and oh, that's small, I apologize. So, oh, I forgot to drop the database. So we got duplicates in there now, right?
Yeah.
So we got 4 back. We should have gotten 2, but I didn't because I didn't drop the database before. But if you, so here's our Dodge that's a 2009, and here's our Chevy that's a 2017. Okay. There are some cool things you can do with your queries here. Let's do another query. Actually, let's just put it there in the same spot. Trucks.find. And let's say we want where make contains substring of HEV, which we should get back Chevy. Database. All right, here we go. Okay, so if we inspect this, we got our Chevy, which is a 2005, and we got our Chevy, which is a 2017. It matches the substring of HEV. When I found out that I could use the contains argument here, which, you know, I use that all over the place in C#. The fact so that the Mongo driver actually takes that command, that library, and converts it into a JSON equivalent, passes that into the database, or into the database as the query. It's actually, I don't know, I think it's super cool. So.
Is there a way you can see what the actual query was generated here?
There is.
In this way, or do you have to go look at your console that you had running in the background?
Yeah, what you would do is you go out to the console and you would run, oh shoot, what's it called? It's a profiling tool basically that you can see all the operations coming in.
Okay.
And the other cool, that tool is actually really useful because you can test, you can see how it's going through the database, how it's finding the different records, and it's determining what records to give back to you. So. And I should actually back up a little bit. There may be a way to see what the query is right here, but it's going to be way inside the Mongo code, the Mongo libraries that we brought in. So, okay, so let's probably need to finish up here pretty quick, but let me just show you guys how to do an update and a replace and a delete. We'll go through these really fast. Stop this. So if you want to do an update, we're going to update a single record. They have this builders thing. You use this to build certain different types of operations. We're going to build an update for a truck, and we're going to set make to a Ford. Then when you want to update certain records, you say update. You can say update 1, update many. I'm going to do update 1. Where the year equal to 2017. So we're going to take our 2017 Chevy. We're going to pass it to update. So what we should see after we run this is our Chevy, which was in the database, should be a Ford. So that's the wrong one. Let's drop the database again. Let's run this. Hold on. So here we have our Chevy that's 2017. We hit the breakpoint right before we actually send the update. Okay, so let's run through that now. And now our 2017 is a Ford. This is what I was referring to earlier when you can update a single property as opposed to replacing the entire document. Let's go through a replace really quick and then a delete, and then we'll be finished. We're going to create another truck. And the make of Dotson. And we'll say it's year is 1978. We're going to replace our Chevy. Well, no, we're going to replace our Ford, which was a Chevy, with a Dotson. So db.trucks.replace 1 in this case. Year and pass it the replaced, in this case, just the full truck object. So set our breakpoint right here. Going to drop our database. Equals. Should be anything there. Okay. Okay, so at this point, at this particular line, the truck should have gone from a Chevy to a Ford. And now, as soon as we run this command, it should be a Dotson. So let's just look. We should see our Ford. And what you'll see actually is the GUID will be completely replaced. Coming up here, when we had our Ford, the GUID here, the ID, didn't change at all. They're identical. The make just changed. What this will do is it's actually going to completely replace the document. So let's run that. I did something bad. Oh, the ID is not overridable. We're going to replace that. Say, what I told you guys a second ago with the ID, that's totally false. It won't change. But we're going to say the make is equal to a Dotson, and the year is equal to 19. This will be. Okay, let's run that. Database, run this again. Okay, so here's our Ford. Run this. Okay. Now here's our Dotson. All right, let's go through a delete operation real quick, and then we'll be done. deleting is super straightforward. We're just going to say db.trucks.delete, and you can delete one, you can delete many. We're going to do a delete many. We're going to say where for the year is greater than 1980. And oops, my bad. Clean up our database, run it. Okay, so we should see, this is getting pretty monotonous. I'm sure you guys can anticipate what's happening. But here's we got our 3 records here. After we run the delete, these 2 should be gone. So let's just step through that. Okay, and all we have left is our Dotson. Okay, do you guys got any questions?
Yeah, so on the delete menu, if you change it to a delete one and you put in an actual model or like an actual entry from a collection, will it delete that entry then?
Yeah, so the way the delete one works is you can pass it the same type of argument. It may find lots of records that actually match that particular argument. It'll only delete the first one it finds. So you could call it multiple times and eventually delete all of them, but it will just delete the first one that it finds. You can also specify rules for sorting those results so that it deletes just one, but maybe one sorted by date. So it would always delete just the newest one or something like that. Here's another question. Yeah.
How portable is this? So can you design your whole database here and then just pick up a file and move it to the server?
Yeah, you can. So, well, ideally, I think what you would do is you would create your application to just build the database on the fly.
Okay.
But if you want, you can.
If you want it pre-populated, certain things.
Yeah. So I was doing this last night. You can say Mongo dump, and then let's see. So you're going to give it a. Okay, hold on just a second.
Oh, you don't have to.
You sure?
Show the guts of it. I just was curious.
Well, anyway, yeah, Mongo dump right here will actually dump out a JSON file.
Okay.
Which then you can import it into your application or into your database.
Okay.
Yeah, and I just did it last night. I just got to pass all the flags the right way. So you would specify, you would say Mongo dump, you would specify the database, and then you would specify the location, and it would create the JSON file there.
Okay. Can you dump it out in JSON too?
Yeah, you can. You can if you want to. Yeah. I just deleted it. Never mind. I deleted it right before I came because I was like, I don't need this folder anymore. I called it dump. Anyway. Are there any more questions? So, I mean, like I said, this is all super simple, right? I wanted to create the application that didn't have a lot of clutter. It basically just did database operations. So it doesn't, I mean, it's not pretty. It doesn't print anything out, but it's really straightforward to, turn this around and drop these into web services if you want to create, a web application that's built on Mongo. And you can actually use Mongo out on Azure now if you want, if you're an Azure person. So, yeah, that's all I got. Thanks, guys. Yeah, thank you for coming.